In Unit 15, Part 2, we were talking about polygons and quadrilaterals. So in Part 1, we talked about triangles, which are three-sided polygons. And now we're going to move on to quadrilaterals, which are four-sided, and polygons in general. So there's going to be a lot of definitions in this section. Just let me know if you have any questions. So let's start by defining a polygon. A polygon is a closed figure whose sides are segments that intersect only at their endpoints. So make sure you write that down. That'll become a little bit more clear as we go through this. A regular polygon is one that has all sides that are the same length. So anytime we say a regular something, it means their sides are the same length. So let's look at some examples. Again, these are all drawings I did, so they might not look very good, and they might not be all that accurate. But if you look on the left, these are just examples of polygons. So their sides are segments, okay, which means they're not curved, and they only intersect at their endpoints. So what they mean by that is the lines only intersect there. They don't actually cross over. They meet at all these endpoints. So imagine all these were perfectly straight lines, because polygons are not going to have curves, but then they only meet at those endpoints. They don't cross over, which makes them polygons. Also, they're closed figures, meaning there's no openings in the lines, which I'll show you in a second. The middle section are supposed to be regular polygons, so just imagine these are all the same length sides. That would make them regular polygons. And the far right side has the ones that are not polygons. This first example is not a polygon because the lines cross over here. So that's where we said they only intersect at their endpoints. Those cross, so they intersect. Number two, or this one right here, is not a polygon because of the curves. Okay? The curves make it not a polygon. They have to be segments, straight lines. And then it's kind of hard to see on the screen. This last one is not a polygon because if you look, there's a gap right here. Okay, so it's not closed, which makes it not a polygon. It's got to be a closed figure. All right, so the next thing we need to know the definition of convex and concave. I'm not actually going to write down the definition because they're complicated. I'll let you come up with your own. But let's look at the examples. So this first one is convex. The reason why it's convex, we can have 2 points. Any 2 points draw a line, and they're not going to go out of the figure. The second one is concave, because if you look, we have 2 points. To connect them, we go from inside the polygon, outside, inside. So this part right here that's outside the polygon in this line is what makes it not, or what makes it concave. So there's no way you can read that. So the fact that that goes outside of the polygon is what makes it concave instead of convex. So I'll let you write down a definition if you want to. We name polygons based on the number of sides they have. So a triangle, tri is 3, quadrilateral, quad is 4, pentagon 5, hexagon 6, hexagon 7, octagon 8. After that, we just use the number. So like a 9-sided polygon, a 10-sided polygon. Okay? So technically it's like I think it's a nonagon for 9, a decagon for 10. But you can just say the number and then say polygon. So for this bottom part, it says tell whether each figure is a polygon. If it is a polygon, classify it and tell whether it is convex or concave. If not, explain why. Okay, so there's a lot going on here. First thing, tell whether the figure is a polygon. This first one, yes, is a polygon. All the lines are segments. They only intersect at their endpoints. It's closed. There's no gaps in it. So it's going to be a polygon. Second thing is to classify it. Okay, classify it is to name it. Okay. This has 12 sides, so we just say 12-sided polygon. I personally don't know the name of the 12-sided polygon. If you want to look it up, go for it. And then the last thing is if it's convex or concave. So these would be, or this shape would be concave. The reason being, I can draw a line from one point to another where it goes inside, outside, inside. That makes it concave. The second one is easy. It's got curved lines, so that makes it not a polygon. Okay, and that's because of the curve. The last one I'll leave for you. You need to tell me whether it's a polygon or not. If it's a polygon, name it, and decide if it's convex or concave. Alright, on the back side, we're going to focus on quadrilaterals. There's a bunch of different kinds of quadrilaterals. Quadrilateral, like I mentioned earlier, is a four-sided polygon. Quad means four. So a four-sided polygon would be a quadrilateral. So we're going to look at a bunch of different examples here. The first is a trapezoid. It's a quadrilateral with exactly one pair of parallel sides. So I'm going to draw examples, so obviously these aren't going to be necessarily all that great, especially if my marker's not going to match up. Okay, so imagine that I drew that better. My marker's not letting me close up all these. Okay, so imagine those straight lines all at this way. So it says a trapezoid is a quadrilateral with exactly one pair of parallel sides. So these sides are parallel. The top and the bottom are parallel, okay? But the left and the right are not. So that's going to make it a trapezoid. So let me try to draw a better version of that. Okay, so here's my better attempt. My markers aren't syncing up right, so it's hard to draw. But if you look, the top line, okay, this line up here and the line down here are parallel. So I have one set, the left and the right. So here and here are not parallel. So one pair of parallel lines is a trapezoid. Next up is a parallelogram, which is a quadrilateral with both pairs of opposite sides parallel. Okay, so again, imagine that I drew that better, but the point is that the left and the right are parallel to each other, and the bottom and the top are parallel to each other. Obviously, all four can't be parallel because they close up, but both pairs are parallel. The next one is a rhombus. A rhombus is a parallelogram with four congruent sides. Okay, so a common looking rhombus would be like a diamond or a kite shape. But imagine that all four sides are congruent. So those tick marks are what going to tell you they're congruent. So and all four are congruent. Next one is a rectangle, which of course you all know what a rectangle looks like, but the characteristics are important. It's a parallelogram with right angles. So these little boxes mean right angles. Parallelogram means that the left and the right are parallel to each other, and the bottom and the top are parallel to each other. So imagine that I do that bottom line straight, and then you have a rectangle. Is it a square? The difference between a square and a rectangle is that a square has four sides that are congruent. So pretend all those sides are congruent. So the tick marks mean they're congruent. The squares and square mean they're right angles. So now we can talk about finding unknown angle measures. So every quadrilateral is going to add up, the angles are going to add up to 360 degrees. So just like we did with a triangle, we can add up all the angles and set it equal to that amount. So I'm actually going to do number 2 because I think it's a little bit harder, and then number 1 for you. But all my angles will add up to 360. So I have 12x minus 17 plus 20x plus 17x minus 17 plus 15x, and all that adds up to 360. So I can add all of my x's together, so 12x, 20x, 17x, and 15x. I add up all those x's and I'll get 64x. And I have negative 17 and negative 17 can go together. That's being negative 34. And that equals 360. Then I just have a two-step equation, so I add 34 to both sides. So I get 64x equals oh man. So I did that wrong. Well, I only messed up one part, so bear with me. So it's 12x minus 17 plus 20x. And then it's 17x minus 7. I accidentally wrote 17 there as well. Plus 15x equals 360. So that's going to give me 64x minus 24 equals 360. Add 24 to both sides. I'll get 64x equals 384. I can divide by 64 on both sides. And I'll wind up with x equals 6. Now, so the question just asked me to find the value of x. If I didn't want to find the angle measures, I could just plug 6 in for x and work it out to see what I get. I finished up number 1. If you have questions, especially on the drawings, my pen wasn't really working, feel free to ask.